Hey guys, we are on day 2 of our Polygon slash, quadrilateral unit here. The very first part here has a warm-up question. I'd actually like to save this part for class. So write yourself a little note to say we're going to save it for class here, because that'll be a good little review to do together. All right, the new stuff. We're talking about exterior angles of a polygon. So first things first, exterior angle means we're talking about the angle on the outside of the diagram if you extend, a side length. And there was an exterior angle theorem for triangles, and there's an exterior angle rule for just any polygon. So what you want to look at here is, can you add up all the exterior angles? So you've got 3 exterior angles since there's 3 interior angles for a triangle. So if you grab your calculator and we add up 147 plus 81 plus 132, we end up with 360 here. So just to make it clear in your notes what we actually added, go ahead and write that down. All right. So the sum comes out 360. This next one, you've got a pentagon because you have 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 exterior angles. I want you to do the same thing. So if you add up the exterior angles here, so add up the 111, 41, 55, 110, and 43. Mm-hmm. So 111 plus 41 plus 55, 110 and 43. And you're going to see that we get the same 360 degrees. And now what's kind of cool is you just saw an example where it was a triangle and you added up the 3 exterior angles, pentagon, 5 exterior angles. So when it says, what is the sum of the exterior angles for any convex polygon? It actually turns out that it's 360 no matter what. And now to kind of show this to you, it is not a dynamic explanation, but I think you can kind of get a visual for it, is if I take the triangle that we had above here, I'm just going to draw kind of a general triangle, and I extend the sides so that you can see here's my exterior angles that we added up. I'm going to start to shrink that triangle. So I'm going to draw it again, but just a bit smaller. And so here's the exterior, and so on. If I shrink it one more time so that it's this teeny tiny little triangle, and I extend, right, we get here, here, and here, you start to see that as the triangle shrinks, you almost end up with just a single point in the center. And if I take those 3 exterior angles here, here, and here, what I really end up forming is just a circle right about that center point. And we know that a circle has that full 360 degrees. That's the reason this is working out the way that it is. So it doesn't matter what the shape is. As you kind of shrink the shape, you end up with that same result there. All right. All right, so on the second page of the packet, there is a space here for all of those formulas that you now know. So the sum of the interiors is 180 times n minus 2. To get one single interior angle, 180 times n minus 2, and then divide it by n angles or n sides, same thing. And then this newest one, the sum of the exterior angles, it's 360, no matter how many sides there are, 360 degrees. And then to get one single exterior angle, if it's a regular polygon, just take 360 and divide it by n. So for all of those, n represents the number of sides. Which is also the same thing as the number of angles in the picture. All right, so let's try some practice. I hope you have your calculator nearby. It's saying find the measure of the exterior angle for each example below. So regular pentagon, regular octagon, regular hexagon, regular dodecagon. For each one of these, you can use the diagram if there is a diagram, or you can simply use the idea, right, that if we know the exterior angle adds to 360, and this is regular, then I can take 360 and divide it by, pentagon means n is 5, divide it by 5. So if you grab your calculator, 360 divided by 5, that should be 72 degrees. So that's the measure of that angle right here. For regular octagon, same thing, total of 360. Octagon means that n equals 8. So when you divide it up 8 ways, 360 divided by 8, we should get 45. Right? So the more sides you have, the smaller the exterior angle actually becomes. So the interior angle is getting bigger, but the exterior angle then is getting smaller. So it's got a little inverse relationship. As one goes up, the other one is coming down, right? Hexagon, n equals 6. So 360 divided by 6. That exterior angle is 60 degrees right there. And then as for a regular dodecagon, I'm not even going to pretend that I can draw a regular dodecagon, but we should recognize that means n is 12. So 360 divided by 12. Each little exterior angle is going to be 30 degrees because there's more sides than all the other ones. And so that exterior angle keeps getting smaller and smaller. When we flip on over to the next page, we look at some problems that look pretty similar to what we did on the first day, but instead of the interior angles being labeled, it's just the exterior angles. So when it asks you to find A for polygon RSTUV, right, you have to think all of those exterior angles add up to 360 total. And so to set up our equation, we would take and add all of the exterior angles. So 7A plus 2A plus 3A plus 6A, and then plus another 2A here. And then we can set it equal to that 360. So when it was an interior angle, you had to calculate the interior angle sum first. In this case, the exterior angle sum stays constant. So we're just adding up the coefficients. So here, when we add these guys up, what we should be looking at, so that's going to be 9, 12, plus 8 more, that'll give you 20A equals 360. So divide it by 20. So if we do 360 and divide it by 20, I can show my calculator here if you need it, that's going to give us 18 right there. It doesn't ask us to solve for any particular angle, so that's as far as we go. Now for number 2, when it says how many sides does a regular polygon have if each exterior angle measures 18 degrees. This is where you can plug into the formula for the exterior angle. So if you think of the way the formulas are written, to get one exterior angle, it's equal to 360 divided by n. So that 18 would go in over on the left-hand side here. So if we do 18 equals 360 over n, to solve this, we would need to get n out of the denominator. So we would multiply both sides by n. That would allow the n to cancel on the right. And you would just get 18n on the left equals 360. And then divide by 18. So if we do 360 and divide it by 18, we come right back to 20. So it's actually the reverse of the last problem right there. So when it says how many sides does the regular polygon have, the answer would then be 20 sides. If I asked you to name it, there's really not much you can say here. I know there is a name. I won't lie, I don't know it. So we would call it a 20gon, right? So 20 sides, or you can say it's a 20gon. Either way would be fine. Right? But what's something you might realize is that even though we plugged 18 in on the left side to solve for the denominator here, what we ultimately ended up doing in that last step was just taking 360 and dividing it by 18. So you can actually plug it in here, even though we're not solving for the exterior angle, we're being given the exterior angle. So it's just like a little shortcut if you happen to see that. We're going to skip 3. We'll call that, or we'll save that one for a little recap for class. All right. Let's jump on down to number 4. So number 4, how many sides does a regular polygon have if each exterior angle measures 22.5 degrees? Right. So if we're looking at 22.5 degrees, then same type of thing. That would go in on the left. The 22.5 equals 360 over n. But like we said last time, you can kind of flip-flop these, and you're going to end up just dividing to get the answer. So if we take 360 and divide it by 22.5, we get 16. Now, something to keep in mind. 16 represents the number of sides in the polygon. So we need to make sure that we're always getting whole numbers for n, right? The number of degrees, yeah, that can be a decimal or a fraction. That's perfectly fine. You can have half of a degree. We cannot have half of a side. So make sure when you're answering the questions that it makes sense what you're coming out with there. Now, as we move into the next page, there's definitely some mixed practice. We'll pick a few to do together, and then a few we will save either for a post-video question or for a recap in class, right? For the very first one, it's saying, whoops, sorry, I'm off the screen. In an equilateral triangle, what's the difference between the sum of the interior angles and the sum of the exterior angles? So when it says, what is the difference? It literally means we want to subtract. So we're talking about an equilateral triangle. All right, the interior angle sum. So I'm going to kind of abbreviate here. The interior angles, those add up to 180. The exterior angles, if we extend these guys out, well, we know that no matter the shape, that's always 360. So what is the difference between the interiors and the exteriors? That would be 360 minus 180. It would be a 180-degree difference there. Okay. Don't worry about positive versus negative. They're just saying how much, different are the two values. Okay. When we look at one like number 2, this is an old Regents exam question. It's saying you have a pentagon that is drawn, and it's formed by these 5 rays. So they're extending out each side. What is the measure of angle X? I like this one because it's testing the concept of, do you recognize that the exterior angles add up to 360? But then also, are you looking closely at the diagram? So 68 is an exterior angle. So is 84. So is 60. 40 is an interior angle. So to get the exterior angle, because they form a nice straight line together, any interior angle, if we have something like this, right? Pretend to draw a picture here, and its exterior angle together have to add to 180. They're supplementary. So the fact that you have 140 means the exterior angle is 180 minus 140, or 40 degrees right here. So that's the thing you need. If you look at it too quickly, it's easy just to grab 140 and go, but that's not what you need. So 68, 84, 60, 40, and your final exterior angle of X are going to add up to 360 degrees. So if we can add all those up and set them equal to 360, then we can solve from there. And so let the calculator do the bulk of that work. So 68 plus 84 plus 60 plus 40, that's going to give us X plus 252. And then you can subtract that from 360. And so we land with 108 degrees. That is that remaining exterior angle there. All right. Let's skip a little bit. If we jump to, let's see, number 4. Let's take a look at that guy. Number 4 is saying in the diagram of a regular pentagon. So they're telling you all those sides are the same. So that right off the bat. EB is drawn. So that's one of the diagonals. That's all that is. What is the measure of angle AEB? Right. Cool thing about this question is they're not asking you a ton about, well, I shouldn't say that. I was going to say they're not asking you a ton about the pentagon, but they kind of are. But what they're hiding in here is, if I kind of highlight, by drawing that in, you have a little triangle right here, specifically a triangle where 2 sides are equal to each other, which means you have a little isosceles triangle, AEB, in the question. And we know in an isosceles triangle, there's 2 congruent sides, but there's also 2 congruent base angles. So I know that this little angle that we're looking for is congruent to that little base angle right there. Right? What I need to know is what that top angle is first. So that's one of the angles in the regular pentagon. So when we think regular pentagon, that means interior angle sum. That would be 180 times n minus 2, or 180 times 5 minus 2. So when you do 180 times 3, that'll give you 540. If I take and divide that up 5 ways, each angle here is 108 degrees. So each of the big angles, here, 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 and here. Now, if I just look at my little triangle, I've got 108 on the top, and I know the other two are equal to each other. So to get those remaining two angles, we can use the fact that a triangle sum is 180 degrees. So if we do 180 minus that 108, that's going to leave me with 72, and then divide it equally. When we divide 72 in half, each of those little base angles are 36 and 36. I like that question. It's a lot of stuff going on right there. All right. With that being said, let's see. I think the very last question, number 6, how many degrees are in each interior angle of a regular polygon if the sum of its interior angles is 1440? So they're giving you the interior angle sum. You're going to be using the 180 times n minus 2. So if they're giving you this piece of it, can you figure out what that is? That is what I want you to answer for your post video question. All right. So we saved a couple for recap. Anything we skipped, we might go back to and chat about in class, but that's the one I want you to finish up. So good luck with it. Go answer that question, and I will see you guys soon.